When it comes to diagnosing even simple concerns like a no or hard start, the processes that we're used to using just simply don't apply. And this Ford F-350 dually, equipped with the often criticized 6-liter diesel, is a prime example. It's also the topic of this month's edition of The Trainer. This edition of The Trainer is sponsored by Autel. To learn more about the entire line of Autel diagnostic tools, visit www.autel.com. Let's take a no start, for example. On a gasoline engine, we only need to check for 3 things. Is it getting spark? Is it getting fuel? And does the engine have the mechanical ability to compress the air-fuel mixture? But on a diesel, it's a whole different story. The first major difference is that there is no spark. Diesels are compression ignition engines. They rely on high compression pressure to heat the air charge to over 1,000 degrees Fahrenheit. Then, just before top dead center on compression, the fuel is injected into the combustion chamber, and the heat of the air charge results in a spontaneous combustion of the fuel. Now this 6.0, for example, has a compression ratio of 18:1 as compared to a typical gasoline engine ratio of 10 to 13:1. A few other differences to keep in mind is that few diesels are equipped with a throttle plate. And if they are, it's for emissions and not engine speed control. Engine RPM is controlled by how much fuel we add to the air charge. And that's another difference to keep in mind. Not all diesels are equipped with injectors that you're going to be used to seeing, as you would on a port or even GDI system. In this case, the Ford 6-liter uses an hydraulically actuated electronic unit injector, also known as a HEUI or HEUI. This unique design uses high-pressure oil to pressurize the fuel charge in the injector. The high-pressure oil fills a cavity above a plunger called the intensifier plunger, and this in turn applies force on the fuel contained in the fuel cavity and the nozzle of the injector. Once fuel pressure is great enough to overcome the force of the spring on the nozzle valve lifts from its seat and fuel is atomized through the injector nozzle and injected into the combustion chamber. The injectors also require a pretty high voltage to open the poppet valve that lets that high pressure oil in. This is the job of the Fuel Injector Control Module, or FICM. Well, that's definitely a lot more than some of us gas guys are used to, but that doesn't mean you can't be just as competent diagnosing a diesel as you are its gasoline cousins. And the first step is to consider, what does it take to get that diesel engine to start? And we're going to start the process by using what God gave us, our senses, our sense of touch, smell, in this case, hearing, and most importantly, that thing up here between your ears, your mind. In this case, attempt to crank the engine and listen carefully to the cadence as it spins. Is it turning over at a normal speed? Does it sound like the cylinders are pushing back as they're being pushed up by the crankshaft? An engine, gas or diesel, that has a mechanical compression loss in one or more cylinders is going to sound distinctly different when you attempt to start the engine. Now, if you suspect that it's a compression-related issue in your diesel no start, then you have to do a manual compression test to see what cylinder is causing the problem. Well, maybe, maybe not. Testing the compression with a traditional method on a diesel can be a real challenge. Unlike the gas engine, you can't go in through the spark plug holes. You either have to go in through the glow plugs or the injectors. And that can be a challenge to get to all by itself. In fact, the flat rate for performing that test on this engine is over 3 hours. So I'm going to apply a little something that I learned in my gas days. It's called a relative compression test. And we're going to use a tool called a high amp probe to measure the starter current draw and its impact on each cylinder as it rises up to TDC. You see, if the cylinder is good and tight, it's going to take more current draw, more work by that starter to push that piston up and through the compression stroke. But if nobody's home and there's no compression to push against, the starter is going to have a lot easier time. And I can see that when I look at the current pattern on the scope. So what do you say we try this out and see if it works? I've never done it on a diesel before. Let's see what we can get on the MS919 scope and get an idea of what's going on inside. Let's try another experiment while we're at it. You can see these same variations in the changes in battery voltage, so if you don't have an iamp clamp, this may be an option for you. We're going to begin by setting up the channels. Using the high amp probe, we'll put that in channel 1, and we'll connect the battery to channel 2. All right, now with the probes in place on the battery, and connect to the VCI out under the hood. I can do the rest from right here in the car, or truck rather. First we're going to select the scope from the menu. Let it connect to the VCI. And then we're going to set up our channels. Now remember, we have the the high amp probe on channel A and just a regular direct lead on channel B. So let's set that one up first. Because we're using a high amp probe, we have to let the scope know that we're doing that. So we've used the 650 amp current clamp, and we've got it set on the 1 millivolt equals 1 amp range. So we're going to make that selection. Now we can go to the amplitude setting. Let's say we want to screen, say 500 amps. We'll start with that. And now we're going to go on to the B channel. Again, this is a times 1, so that's K. Amplitude setting. Here's where it's going to be a little different. You're used to me setting this to the 20 volt scale, but I'm not interested in the actual voltage reading. I'm interested in the change of reading. So I want to be able to see that easier by changing this to an AC coupling. So that's going to take the DC component out of the signal and focus just on the change. So let's start with, let's see what happens when we do a 1 volt scale, and we'll see what kind of change we get there. And now we need a trigger. So we'll select the trigger base. I'm going to use a single because I want it to stop when it fills the screen. We'll stick with the channel A, the amp probe, and use a rising pulse direction, rising trigger. And let's just set that, for 10 amps. All right, you can see that we have a dot. I'm going to move that over to this side of the screen a little bit. And so we get it started over on that side of the picture. Next thing I want to do, I'm going to leave that there. I'm going to leave the voltage where it is. We've got our, next thing we still have to set the time. Again, you've heard me say the 20-20 rule, 20 milliseconds per division, 200 milliseconds across the screen. But that's for an engine running at idle, 700-800 RPM. The cranking speed here is going to be closer to a few hundred RPM. So that's about a quarter of that. So I want to get some more time on the screen. I'm going to go with 500 milliseconds per division. I can always back that down, okay? So we're going to close that off. We should be ready to go. We're going to turn our scope on. Let's see what happens. There we go. Now we're getting across the screen. I like that. All right, so let's take a look at what we got here. Pull that out of the way so it's not dinging in our ears. The upper trace is the current pattern, and what you're looking at here, each triangular shape, each little pyramid you see, is the amount of current being drawn by one of the cylinders as it reaches that top dead center of compression. It's taking more energy to get that starter motor to help push that piston through. So if there was a weak one, then it wouldn't take as much energy, and you would see that variance here on the line. Same thing here on the voltage, only here we're looking at the change in voltage and the voltage being pulled down. So when it's being pulled down, again, we're looking for a uniformity here in the drop. A weak cylinder is just going to stand right out at you. And these are relatively accurate. Let's, for giggles, let's see if I can reduce that scaling a little bit and make that current pop out a little more. We may have to pull that down. There we go. And I want to show you this because see how this is, it's almost a mirror image. It's almost a mirror image of the two patterns. If I do experience a problem with a slow start or a poor cranking, then I want to go ahead and make sure that I test the batteries. And since most of these have a dual battery system, I need to make sure that I isolate the batteries so that I can test them accurately. So I'm just going to disconnect the negative cable here on the driver's side battery. And there are a couple of tools I have in the shop that can do really well for this test. One is the Autel BT608. It's a handheld unit. And also there's this model. It's the BT506. It actually connects by Bluetooth either to your scan tool or to an app on your phone. So let's try this one out. I'm going to go ahead and attach this to the battery. Again, always positive first, then negative. And then we're going to pull the phone out. And so this is what the app looks like on the phone. I'll try to keep the picture nice and clear while we go through the test. We're going to go ahead and select in-vehicle test. And then it asks you to complete some vehicle information. Most importantly, I want to make sure that I choose the correct battery construction type, what rating system I'm going to use, and then the rating itself. In this case, this is an 850 cca battery. Once we have that in place, we'll go ahead and hit next. And then it's going to ask us to get the vehicle ready for the test. Make sure the key's off, electrical accessories are off, and all the doors are closed. So we're going to make sure we tick that off so the app knows that we've done that. And then we're just going to hit start test. All right, so it's telling us, and I want you to be careful when you read this. Notice that first reading says SOH. That's state of health. It's giving me a 93% state of health. It's telling me to charge the battery up, maybe retest it when I'm good. But the state of charge is pretty low. It's only 36%, 12.09 volts. So this battery is undercharged. We need to charge it up and retest it. If it doesn't come up to where we need it to come up to, well, that could be contributing to my problem. It could not, maybe it's not producing enough voltage to feed the FICM. Of course, cranking speed, things that we've already talked about. If that's the case, I'll need to replace the battery and then retest the system again. So let's recap a bit to where we are to this point. When you're performing that cranking test, I want you to pay particular attention to the cranking speed of the engine. How fast is it turning over? You know, a low cranking speed is an issue on gas or diesel, but especially so on a diesel. Remember, these are compression ignition engines. They rely on the heat generated in the air charge by that compression process. And if the piston's coming up too slowly, that heat is not going to reach the value we need to ensure a spontaneous combustion of the fuel when it's injected. If you have an issue with cranking, speed, if something doesn't sound right, it's always a good idea to check the battery condition, regardless really of the scenario that you have, because so many things are affected by the battery condition itself. Now in this case, we did find that the driver's side battery was questionable. This could be influencing the charge going to the fuel injector control module. Remember, we need high voltage, so we need to send enough voltage to the FICM so that it can boost that up to the 48 volt level or higher that we need in order to operate the injectors. Now the other thing we want to make sure that we do is fuel under hood checks, because they're specifically related to the type of injection system that we have on this truck. Let's talk a little bit about that. First, you want to make sure when you're dealing with a no start or hard start drivability issue on a diesel that you understand what type of injection system is being used. There are a few different kinds. Older diesels use what was called an electronic unit injector or a manual unit injector. Many of these were actually driven by a separate camshaft that would actually force the plunger down on the injector, and that would generate the high pressure in the fuel chamber in the injector itself. In this case, that job is being done by high pressure oil being fed to the injector. And then many of the late model stuff that you're going to see are common rail systems, very, very similar to the GDI designs that you're getting familiar with now. It's very important to understand how this is done, because we have to have that high pressure fuel in order to open the injector and get it into the combustion chamber and make that truck or that car run. You know, keep in mind that just like GDI, we're injecting the fuel right before TDC compression. So we have a very narrow window of time to get the fuel we need in there. So we want to check on this particular truck, very important to check the oil level, make sure that it's full. If it's low, that can cause aeration in the oil that's going to interfere with the injector's ability to produce the pressure necessary. Could even lead to damage of the injectors. And we want to check the fuel, the quality, and of course fuel pressure that's feeding the system to begin with. You know, in this vehicle there are 2 filters, and you know how bad customers are with maintaining their vehicles. It's very likely that those filters haven't been changed for a while, but you want to encourage any of your diesel owners to make sure that they keep up with their oil maintenance and they keep up with their fuel filter maintenance if they want to make sure that that vehicle helps last a long, long time. And diesels hate water in their fuel. Be sure to check the fuel for signs of water contamination or the water and fuel warning message on the instrument panel. Now to this point, I'm pretty confident that there's no mechanical issues with the vehicle in terms of compression. And while we're under the hood, we took care of checking the oil and fuel quality to make sure that they were okay. At this point, it's a good time to hook up the scan tool and start looking at some data PIDs that are particular to this type of system. So what do you say we go ahead and hook up a scan tool, and we'll do that next. So we hooked up the scan tool, select that from the menu, and very quickly the vehicle is identified for us. We'll go ahead and select the vehicle. I'm going to use a standalone diagnosis. VIN is correct. We're going to make sure that all the information here is correct. It is. And now we're just going to allow the system to populate for this specific vehicle. Now, you've heard me say this before. Whenever I'm connected in an enhanced data mode, a factory-specific data mode, then I want to select auto scan. So I can check all the systems on the vehicle at once. Something might be related to my problem, may not be, but if there's issues in any of these other modules, I need to advise my customer of what I found and recommend the next steps for them. We already see that we've got code stored in the PCM, the powertrain control module. What I like about this topology map too is that you can see that the modules are linked by different color lines. These indicate the networks that they're on. So the red is a high-speed CAN network for these modules, and then we have the ISO 9141 here on the center, and then we have a universal protocol here for the last 2. So we've got some code stored in some of these other systems. We'll go ahead and look at the report real quick, really focusing on the drivability ones at this point. So if I see anything related to that, then that's fine. Okay, so here we see what we got. We got a problem with the FICM control module performance, cylinder number 5 glow plug, FICM supply voltage circuit low. Well, I've already explained that when we were doing the relative compression test, I unplugged power to that, so I know what those are from. And we talked a little bit about glow plugs. Let me just stress here that glow plug circuits, the glow plugs, what they're for is to preheat that air charge when the weather is cold. And not a real factor here where I'm at down in Florida, but if you live up north, then that's a very real issue you need to consider when you're diagnosing, especially any kind of hard start condition in the cold weather. I will tell you this too. It's possible for there to be a problem to be with the glow plugs and not have a code set. If it's in the glow plug control module, then odds are you'll have a code set. But just because you don't see any codes here, don't discount a problem with the glow plugs quite yet. Okay, we've got codes in here for battery voltage, some other issues in the CAN. Not going to worry about those at this point in time. Let's see what we first focused on, that hard starting. Oh, back to that. Using the intelligent diagnostics function. So I can pull those codes up and we can go to, let's just say, the performance and see what we find out. And we can get a variety of help here. Testing help, repair help, wiring diagrams, component locations. These are really nice. For example, if I go ahead and hit that, this is going to connect me to the motor information service right there in the tool, so I don't have to go anywhere else and look. and I can pull up the information there. It'll tell me what's going on, what pinpoint test to do, and so forth. So this is a really great resource to have right there in vehicle, right? So let's see, we'll get that back up. So there's some really great resources, again, like I said, right there at your fingertips. All right, so let's go directly to the PCM. And we'll take a look at live data. Now there are a lot of PIDs here. Again, we're in the enhanced, the factory mode, so there are a ton of PIDs in here. I don't want to spend time looking at every single one of them. I might scan the list to see if anything really stands out as a warning sign in front of me. But for example, if I'm dealing with a starting issue, a drivability issue, I'm really not concerned about what the air conditioning clutch is doing. So the key is here to just pick the PIDs that you think are going to impact what you're trying to diagnose. So let's kind of scroll down the list. And one of the very first ones I'm going to pick for this one is whether or not the camshaft and crankshaft sensors are synchronized. If something's out of time, then that's going to stay no, and it's not going to change. If there's an issue with the sensor, we should have a code stored, but not all the time. So I always take that with a grain of salt. So we're going to take here again, we're going to pick that one, that's once for sure. And then we have to remember what it is. Well, let me talk about that first. This just kind of tickles me here. We got cumulative number of misfires and all the different cylinders are listed. Of course, we're not showing anything there on the data screen. But what I just want to point out is the term misfire that is so often misunderstood. One of the most common things techs do when they see a misfire code is to start throwing spark plugs and coils at it. But hey, this is a diesel. There's no spark plugs and coils to install on this engine. So when you're looking at a misfire, you're looking at something that cylinder is not contributing 100% of its share to the engine. So that's what you want to think of in a misfire and what kind of conditions would cause that to occur. Now, in a diesel, it's either going to be in compression or it's going to be in the amount of fuel that's getting into the engine. There is no spark per se to worry about. We'll get down there. This popped up already, so I'm going to throw that in there. Desired idle speed. Desired is kind of cool. When you're reviewing scan data, especially if you've been around for a while, a lot of times you don't know what some of these data PIDs are supposed to be. All right, and the desired PIDs you see are what the software engineer has plugged in as the value that it wants the ECM to obtain. That's the target. In other words, the engineer is saying, when you see this and you see this and you see this, do that. Well, that's the do that part, in this case for the idle RPM. So if I have a desired and an actual, I can compare the two and see if they're close to one another. All right, we'll continue on down. All right, here's some information on the FICM. We're going to go ahead and check those off. We've got power fused from the FICM module. We have internal injection power. That should be reading about where you see it, 48 volts. That's the voltage that we need to open these injectors. If we see something cranking that's dropping below that, or it's way low, or these numbers are not where they need to be, that's a red flag that we need to investigate. All right, now here are coming some others that we need to pay attention to. Remember, an HEUI system like this one, hydraulically actuated control electronic unit injectors, they work, or they build that high pressure fuel charge using high pressure oil that's allowed into that injector assembly. So I want to know injector control pressure. I want to know what the sensor reading is. I want to know what the desired pressure is. And I want to know what the injector control pressure regulator is doing. The injector control pressure regulator is what alters the pressure from the high pressure oil pump to the injector. Desired, of course, we talked about. That's what the ECM objective is. That's what it wants to see. Injector control pressure actual is what's actually being reported, and it's being reported by the sensor. So we want to have all that information in one spot. I can tell you right now, let's see what else we got here. I won't tell you right now. You'll have to wait. See what else we might see here that we might want to include. Got some geometry in the turbo. All right, so we got those. I'm just going to show the selected. And I'm going to go ahead and I'll tell you what I'm going to do here. I'm going to go ahead and I'm going to also graph these injector control pressure numbers so that we can talk about those after we get some data. And in order to get that data, I'm going to hit record, and we're going to go ahead and start the engine. And I'm going to give it a few blips here because I want to show that. All right, so now we have some data on here. Let's talk about what we've got. I got a few additional notes for you on the scan data, but I want you to remember that it applies specifically to the 6.0 Ford Power Stroke. You always want to check your service information system for the information related to the vehicle that you are trying to troubleshoot. And again, one of the things I said you want to make sure you understand is just how does that fuel end up in the combustion chamber? What type of system is being used? On these unit injectors, no matter the design, the high pressure is built up in the injector assembly itself. And on the common rail design, it's a separate high pressure pump, very similar, as I said earlier, to the GDI systems that you're working on today. So in this case, when it comes to the oil pressure, this high pressure oil pump has to generate at least 500 PSI in order for the injectors to open. So if I'm cranking the engine and I don't see that value building, that's a concern I need to diagnose a little further. And if you also recall, we looked at the relationship to the injector control pressure desired. Remember what that meant? That means that this is what the engineer's target value is, that the ECM is expected to reach. And then we have injector control pressure actual. And then we looked at the injector control pressure sensor reading. Now this is critical because that's the feedback that is going back to the ECM to let them know what's going on. It doesn't know exactly what's happening. It has to rely on that information. So if you see that that is erratic or is much lower than the reading that you're seeing on the desired and actual readings, or you suspect there's a problem with it in any way, shape, or form, unplug it and then try it again. When you unplug it, it should default to about 750 PSI. So if the engine does start and run after that, well, then you know it's just a sensor failure. Finally, if the ICP desired is significantly higher than the ICP actual, the IPR valve may not be functioning correctly and allowing oil pressure to bleed off. A high pressure system leak or bad high pressure oil pump can also cause this condition. But always verify IPR function before assuming a high pressure oil system leak or high pressure oil pump failure. Here's a tip when you're dealing with a hard start or no start in cold weather. Pay attention to the tailpipe. If you see white smoke puffing out of the tailpipe while you're cranking the engine, you could have a problem with the glow plugs or the intake manifold air heater, depending on the system installed on that vehicle. In cold weather, as I mentioned earlier, we need those glow plugs to heat up or preheat the air charge so that we can reach the temperatures we need to heat in order to create that spontaneous combustion. White smoke is indicative of raw diesel fuel that has not been combusted, and that's what you're seeing coming out of the tailpipe. Another test that you can do to help you gauge what's going on with the injectors is called a power balance test. So let's go ahead and access that. And here's the protocol for setting it up. It's basically making sure that we got the engine running, we're not going anywhere. We're going to put it into reverse, keep our foot on the brake so it's not going anywhere. Put a little load, and now we're going to start it up. Now, what you're seeing here is represented by cylinder 1, 2, 7 in firing order, okay, all the way across the bottom. And this is the amount of power being contributed, or variance rather, by each cylinder, by each injector. Now, let me clarify that. On a compression ignition engine, only two things are going to affect this graph. Either the compression, mechanical compression, which we pretty much have said is okay, or something going on with getting the right amount of fuel into the combustion chamber. So this is a good way to get an idea of what the injector strength is and how it's doing. Okay, I can also select the cylinder balance and see what it does. I'm not going to do it for long, but you can see here how much drop we got when we shut out the fuel to number 1, so we can see how much of a contribution that made. And I can go across the board, for all of the cylinders to see if that's relatively equal. That's also going to give me an idea of the flow. No doubt, doing any kind of diagnosis on a diesel, especially drivability related, is a little different than what you're used to on a gasoline engine. But the skills that you've mastered in the troubleshooting and diagnostic process will serve you well when you make that conversion to the diesel family. Now, if you'd like to know anything more about the tools that I used in today's videos, please visit www.autel.com. And as always, thanks for watching.